Notice that in the sentence that we described in the last example, the words any or for all did not show up anywhere, but we were still able to determine that this was a universal statement. We said that the universal statement was implicit. Existential statements can also be implicit. For example, saying that 24 can be written as the sum of two even integers is an example of that. What we're saying basically is that there are some two even integers that when added together will be equal to 24. So this is an example of an existential that is implicit. Universals can also come in different flavors. For instance, if I say the words, all squares are rectangles, then someone will understand the following. For any object, if that object is a square, then the object is also a rectangle. More formally, somebody could write the following. For all x, if x is a square, then x is a rectangle. And again, we can use this function notation that I described previously to simplify the words even further. So for instance, I could write for all x, comma, square, parentheses x, implies rectangle, parentheses x. In other terms, I'm treating the square and the rectangle just like functions that accept a variable called x. Similarly, existentials can come in different flavors. For instance, there is an integer that is both prime and even, means that some integer out there is prime and the same integer is also even. Let's practice by rewriting all the children in Tom's family are female. We would like to rewrite this in if-then form. So first of all, this is an example of a universal because I'm hearing the words all. And we can interpret it like this. For any x in Tom's family, if x is a child, then x is female. So that's one possible solution. Or if I want to simplify it even more and use symbols, I can write for all x and describe the domain of x, which is Tom's family, comma, child x, meaning if x is a child, implies female x. So x is a female. Here we go one more time. All the females in Tom's family are children. Again, this is an example of a universal statement, and I can interpret it like this. For any x in Tom's family, if x is a female, then x is a child. And using the symbols, we can rewrite it in the following way. For all x in Tom's family, so that describes the domain, female x implies child x. Again, we're treating female and child as a function that accepts the value x.